explanation is mostly gonna be from the book, all right? From the book. But if I have to jump into the board, I will do that. All right, let's begin with modeling. What is modeling? All right, modeling is the idea, the word is the word for using data and express it in an equation, in a function. That is modeling, all right? In simple terms, right? Of course, modeling has more intricate and complicated and special definitions for something, for certain areas. But mine is what I feel is the easiest to understand. What is modeling again? What is modeling? If I ask you to find a model, all right, go ahead and find a model. Finding a model means finding the function to better suits the data. Go ahead and write it down, please. Finding a model means finding the function that better suits the data. I can see David is writing. I can see Lily is writing. Maf is writing. Karen is writing. Tefa, I think, is writing. Right?
Mister, can you repeat?
Repeat it, sure, absolutely. Modeling, or what is to find a model? What is that? All right. Finding a model means finding the function that better suits the data. Finding the function that better suits the data. All right, cool? Beautiful. So let's begin with this investigation. We're not gonna do the investigation. If we were in the school, though, we will do this investigation. I will ask you to work in couples and that sort of things. We had so many things planned for you guys. We were gonna do so many investigations. This class was gonna be so much hands on deck. You know what I mean? It was gonna be so different. But this virus, man, screwed everything, you know? All right. So the investigation. All right, let's take a look at this. So we have a water tank, right? And the water tank is leaking. Now, the amount of water that the tank has, the amount of water in the tank was measured 3 times, right? So for example, this type of exercises, modeling, can be used for any other subject outside of mathematics. For example, for biology, for, I don't know, environmental, physics, any type of area where you have to measure things. So in here we are measuring the amount of water in a tank. But I don't know, man, you can just measure the increase, the growth in some plants, right? That is something for biology, right? So modeling can be applied to some other areas, and it is the same process. All right, so we're measuring the amount of water in the tank. We measure it 3 times after it starts to leak, right? And then we have this data, right? This data is the amount, is the measurements that we have, right? So for example, this is the time in minutes. So we measure it at 2 minutes. Then we measure it again at 4 minutes. And the final measurement was taken at 9 minutes, right? Here, by the way, if you're following the book, this is page 247, right? Page 247. Then the amount of water that we found in 2 minutes was 1,900 liters, right? Remember, this is in liters because it's the amount of water. Water is measured in liters, right? At 4 minutes, we had 1,800 liters. Now, from here, does it make sense or not? Does it make sense that the water is lower now that the time has passed? Well, yeah, right? Because it says here that the water is leaking. Right? The water tank is leaking. So it's decreasing the amount of water. It's leaking water. It doesn't have the same amount of water, right? Okay. At 9 minutes, this is the amount of water that we measure, 1,500 liters. All right, cool. So again, what is modeling? Modeling means taking the data and finding the best function for that data. So, sure, we have here a bunch of steps and a bunch of guides and all of this, but in reality, I think that the best thing we can do is what says here. always plot the points to see what kind of figure, what kind of function do we get from the points. All right. Now I can see Karen pretty fastly taking her calculator to plot these points. Thank you, Karen. I appreciate it. I don't see nobody else. But all right. So you could plot these points. Right? 2, 1,900. 4, 1,800. 9, 1,500. Right? Now, that is the first step because again, from a bunch of data, you guys are not gonna know what is the best function for that data. You guys are not gonna know until you kind of see the behavior of that data. You kind of see the behavior. Seeing the behavior means plotting it in a Cartesian plane and see if it is linear, maybe it is quadratic, maybe it is, I don't know, right? Now, the more data you have, the better represented a function will be. 3 points are not nearly enough. If this was a real example, for the, I don't know, for example, the one that I did for the growth of plants, right? By the way, I have a student in 11th grade who is doing a monography, the final document in biology, and that is exactly what the guy is doing. The guy is growing 150 plants at his house. He's growing again 150 plants, and he is measuring the growth of each and every one of those plants. Now, what the guy is doing from there is doing a modeling process. And he discovered that the points, simply because he had 150 plants, so he had 150 data, he is finding that the plants are growing in an exponential function, in an exponential way. That's pretty cool. That is pretty cool, right? So this can be applied to everything in life. Man, this can be applied. Look, this can be applied to our currently issue with the coronavirus. Man, do you want to know if tomorrow are we going to have more cases than today or less cases than the virus than today? So what we do is we plot the data that we have from previous months, from previous days, and we try to use the model to determine what is going to happen to the future. You know? So this can be applied to everything. In mathematics, most of the times, this is the main thing that we use data for, to find models. All right, so first you plot it, right? I was just talking a bunch of things to give you time to plot this in your calculator. Did you did it or not? All right, cool. I got some of you saying yes. All right, cool. Beautiful. All right, so you should have, I don't know, maybe something like this, right? Maybe something like this, or down. I think you got it down, right? Thank you, Karen. All right, cool. So the second step will be try to determine what is the best model that we can apply. In other words, what is the best function that we can apply? Are we going to apply a linear function, a linear model, or are we going to apply a quadratic function, quadratic model? Did you see? So in order to model, you need to be very, very good at recognizing the types of models that we have, the types of functions that we have. We have linear functions, quadratic functions, cubic functions, we have exponential functions, radical functions, rational functions, sinusoidal functions, so trigonometric functions. We have a lot of functions, right? A lot, there are a lot of functions. And watching the behavior of your dots, so the data, is going to tell you what is the best function that we can choose. Dani Pérez, profe, ¿puedes ver el correo que te envié, porfa? So you mean right now or later? After the class, right? After the class. Or right now, Dani? Dani. As you wish. All right, after the class. All right, so in this example, look, we're gonna take a look at a real example here, right? We're gonna take a look at a real example here. I'm just telling about what is the idea behind modeling, right? Here we have two new words for modeling. We have extrapolation and interpolation. So what is the meaning of extrapolate the data? And what is the meaning of interpolate the data? All right. Extrapolate, as the drawing says in here, look, the red dots, let me just increase this a little bit bigger. There. The red dots are going to be our data. So in this example, we have 1, 2, 3, 4, and 5 data, right? Extrapolation means taking the data and finding a next point, a point that is outside of the range of the data. Remember, since we have points in a plot, in a plane, we can talk about domain and we can talk about range, right? Do you guys remember that or not? Right, in case you don't remember, let me record this. No. Let me change this. All right. In case you don't remember, domain are going to be the values of X. So from this data to this data, this will be my domain. Let's call this X1 and let's call this X2, right? This is going to be my domain, right? Remember, each and every one of these data are points. Each and every one of these data are points, just like the ones in our example here. This is a point, right? 2, 1900. 4, 1800, right? So if these are points, the first variable is the X and the second variable is the Y. This is what we have here. This has an X variable and a Y variable. The Y variable will be here, right? And this has an X variable and a Y variable, which will be here. Right? Now, the domain is the interval of the data in the X variables, And the range is just that, but with the Y. This is the range. Domain in X, range in Y. The interval of the data in the X's is the domain. The interval of the data in the Y's is the range, right? So look at this. We can take into account all of this data, all of this space. We can take into account all of this space. The data is covering all of this. This is what is being covered by the data, this. Extrapolating means taking and trying to find a data outside of that domain and that range. Look, this data has a Y variable that is outside, Y3, of the range, and an X variable that is outside of the range. Did you get it? That is the idea behind extrapolating, finding a value outside the domain and outside the range. Right, that is extrapolate. But what is interpolate? Interpolation. Right, take a look at this value here, the one in blue. That value is inside the domain and the range. This one, this is X4. I'm gonna call it X4 because I already have X3 here. And I'm gonna call this one Y4. Look at that point. That point has 2 coordinates. And those coordinates are inside, between, in the middle of the domain and inside or between the range. Did you get it? So that is the difference between extrapolating and interpolating. All right, cool. Let's erase all of these. Extrapolating and interpolating. Now, what is that? You can use a model to try to determine values that you don't know. For example, the example that I just did. If you plot the cases of coronavirus in Bogota from the past 3 months and use that model to try to define what is going to be the amount of infected people in the next month, so in August, that is called extrapolating. Because you're using the model and finding a value outside the range. Did you see what I mean? All right, cool. Now, interpolating. For interpolation, I don't know, let's say you, in the same example, right? In the same example, you calculate or you plot the amount of infected people daily, but you don't care about the infected daily, you care about the infected in a specific time of the day. So for example, this is and a specific day. And this is another, this is the next day. These are 2 days. So for example, this is Monday. This is the amount of infected on Monday. And this is the amount of infected in Thursday, right? 2 days, right? But you don't want the amount of infected in 2 days. You want the amount of infected at exactly 8 o'clock. The amount of infected at exactly 8 o'clock. So a point inside 2 given data. That is called interpolation. Right, guys? Why is this important? Because some examples are going to ask you to interpolate or extrapolate. Right. Let's take a look at this over here. Right. This is a good diagram. We're going to explain it later, hopefully. Let's take a look at our first example. All right. Beautiful. Let's begin with the first one. Example number 19. In a chemistry experiment, a liquid is heated and the temperature is recorded at different times, right? So we are heating a liquid and then we are recording that temperature. And then we have this table. So at 4 minutes, the temperature is 130 centigrades degree, right? And then at 6 minutes, we have 209.8 centigrade degrees. All right, we get the idea, right? This is our data. We have 4 points. The first one, plot a graph of this graph using your GDC. Now, you don't have to do it because I have it right here. The book has already done it. This should be the drawing that you have if you do the example. There, this one, right? So we can see the points are going up. This is the first step in modeling. Try to plot the points to try to determine the behavior of the points. Let's go with the second one. Choose an appropriate model and then justify your decision. So what would be the appropriate model from here? Okay, so the point seems to be aligned, so we can say that the model is a linear model. This is the process that you do. You just look at the graph. There is no other process. You look at the points and you decide by your knowledge on mathematics. If you think the point could be showing you an exponential function, then you say the better model is an exponential function. This is just from what you think, all right? Designing the model is from what you believe, what you think is the answer. All right, let's continue. Determine a reasonable domain and a reasonable range for the model. Again, we know the domain is going to be from the lowest x to the biggest x, right? And we can find those in here. The lowest x is 4, the biggest x is 10. So we can say the domain is from 4 to 10. Did you see what I did? All right, cool. Again, this is how you write it, right? This is called set builder notation. I think we saw this in the first term or something like that. This is called set builder notation. So this is the set of the x variables such as 4 is lower or equal than x, lower than equal than 10. This is how you write it. Okay, let's continue with the range. What about the range? Okay, so the range are gonna be from the lowest y to the biggest y. We have those in here again. So our range will be 130 to 369.2. 130 to 369.2. There it is. Let's see the chat. Somebody says something in the chat. Majo, Gus, te escucho trabado. No sé si soy solo yo. Guys, can you hear me correctly?
Yes.
Thank you, Karen. Somebody else? Danny says, bebé, eres tú. Juan David Garzón says yes. All right. Thank you, guys. Thank you. Then Majo, seems to be you. It seems to be you. All right, let's continue. D. Find an equation for the model. This is where the real mathematics come. Find the equation, right? This is the this here. This can be expressed in just one word. Modeling. Right there, modeling. Finding the equation for the model. Okay, so this is what we do. Look at this. For question D, what we can do is, given that we know the model is a linear model, what we can do is use our calculator and find and use the key that says linear regression. Let me just open my calculator and I'll show you in a second. Here. Give me just 1 second, please. There. So you have your calculator, right? You just quit from there, whatever you're doing, right? Clear? And to find models, you're going to go to statistics here. Statistics, right? Now, you want to calculate things, so you go to calculate. And look, there we have a lot of regressions. We can find the linear regression, the quadratic regression, the cubic regression, the quart regression, right? Natural logarithm regression. We have a lot of regressions. Each and every one of these regressions are the keys or the tools that we use to find models. So if I want to find the linear regression, I'm just go down to 4. Linear regression. Enter. But look at that. The calculator is going to ask me for the data. So I need to put the data first, right? So let me just quit from here. Quit. And put the data from the beginning. Stat and then edit. If I want to edit the data here, I just cleared all of these. And clear the second one, right? And from here, I can introduce my data. This is pretty simple. All I'm doing here is introducing the data. Now, you can do this with me if you want to practice. You should be doing this with me, just for practicing. So we have 4, 6, 8, and 10, right? And in the other side, we have 130, 209.8, 290.3, and 369.2. There. Now that we have the data there, what we're going to do is tell the calculator to find the model. Here, statistics, calculate, and then linear regression. Why are we choosing linear? Why are we choosing linear? Why are we not choosing any other model? Why are we not choosing quadratic regression or cubic regression or quadratic? Why are we choosing linear instead of all the other ones? Well, because from the graph, we decided that it looks like a line. So we're choosing linear regression. Enter. The data is there for you to calculate. Enter. There you go. This is the same process that we use. This is the same process that we use to find the R, right? The Pearson coefficient. Do you guys remember this? The coefficient for Pearson. All right. Beautiful. So here's the model. We have A, 39.905. This is the value of the slope. And then we have negative 29.51. This is the value of the y-intercept. All right. So we have our model here. There it is. That is our model. Beautiful. We got it. Congratulations. Now, we can plot it. How are we going to plot it? Simply, we just write down this in the calculator here where it says y equal. So we just put it right there. If we put it there, we're going to find our function, our line. It's pretty simple, right? From here, let's jump into the next question. Here. Comment on your model. Commenting on the model means saying if it is a good model or not, right? And look, since this is the line, it looks like it is a perfect model. So it is perfect. Everything is fine. Use your model to estimate. All right, so we're going to estimate. We want to estimate the temperature of the water at 4.5 minutes. Tell me, guys, in the chat, please. Estimating at 4.5 minutes, is this an interpolation or an extrapolation? In the chat, please. Nope. Nobody? All right, thank you. We have 2 answers now. 3, 4. Thank you, guys. So you have extra, inter. All right, inter. All right. How are we going to know? Take a look at the value and look for the value in your domain and in your range. Look, since we're looking for 4.5 minutes, we know that minutes is the domain. And look at that. 4.5 is between 4 and 10. Remember, if we are looking for a value inside the domain, then we are interpolating. So in this case, 4.5 minutes is inside the domain. We are interpolating in this case. But what about 20? 20 minutes. What about 20 minutes? Find the temperature of the water 20 minutes after the experiment. Is that interpolating or extrapolating? In the chat, please. All right, thank you. We have a lot of extras. Thank you, guys. You guys are correct. Simply because we are looking for a value that is outside of the domain. Look, the domain goes from 4 to 10. We are looking for 20, so we are extrapolating. All right, cool. How do we find this? Pretty simple. Just take the value and replace it in your model. So we know these 4.5 are minutes, right? And we know minutes is our x variable. How do we know that? Because here it says time is in x minutes, right? So this, we're going to replace it for the x in our model, 4.5, right? So take a look at this. Take a look at this. Here's the example, method 1. So you can take your calculator and estimate the temperature graphically. I can show you that in a second. And method 2, we are going to substitute the value, 4.5, in the equation. Now, the equation was this one, right? We had it here. 39.905x minus 29.51, or the one on top, if you want to simplify it. So we're going to replace in that value. We're going to replace in that function. Look, the slope times our value minus, this is an issue. Look at that. This is a big issue. This is a mistake in the book. Look at that. We found a mistake in the book, guys. We should be replacing by 4.5, and we replace by 4.05. We're not doing the same. We're not doing the proper replacement here. Did you see the mistake or not? All right, this goes to show that you cannot trust books blindly. You can read books, you can learn from books, but you have to also try to analyze it and be critical about what is written in a book. Because this is a clear mistake. This is a clear mistake. We should be substituting by this value, and we substitute by a different value. All right, whatever. We just do this, and we have our answer. Right? The same method, we can use it to find the value for 20 minutes. Take the function and replace, instead of x, replace 20 minutes. That is it. Now, how can you do it graphically? How can you do it graphically? This is how. Take a look at the screen, please. From here, graphically means graph. So you're going to have to graph the function, right? I'm going to use this one in here. I'm going to use this one. You know what? I'm going to use this one here. That is the function I'm going to use. So 39.9x, right? Minus 30. That is the function. If I press enter and then graph, I should have the function appearing in a minute. Now, as you can see here, the calculator is processing, right? It's thinking, right? All right, this is my function. Now, of course, your function may appear differently in your calculator because you have different, the window is different for your calculator. So if you want to change the window, you just go to here. Where is that? Window. And you change the values. Let's use values from the domain range that we have in here. Why? Simply because I want to. Simply because I want to. So let's go from x is going to be from 4 to 10, right? Because that is the domain, from 4 to 10. And let's say that y is going to go from 130 to 369.2. I just choose to change the domain and the range because I want to have these same points, right? So if I graph again, this should be my graph. Look at that. This should be my graph. How beautiful is that? All right, graphing, the graphic method is just use the graph to find the value. And this is how you do it. You are going to go to calculate. So second and trace. Again, calculate, the word in blue on top of the key trace. From here, if we want to find a value, we press a value. And look at that. The calculator is asking us, what is the x value that you want to find the y for? Okay, so we want to find the y value for 4.5, right? So I just pressing here 4.5. If I press enter, the calculator is going to tell us that the point is right there. X being 4.5 will give us a value y of 149.55. So really close to 150. Really close. This is the graphing method. And we can also use it to find the value of y. Now, once I do that, the calculator will give me a mistake. Look, second calculate value, and I just press 20 in here. I'm doing this one, 20 minutes, right? I want to find the y value for 20 minutes. Majo says, Gus, voy a salir y voy a volver a entrar. Escucho muy entrecortado. All right, Majo, okay. Right, so if we do this, we can press enter, and it gave me a mistake, just like I said. Why? Why is this happening, guys? Any ideas? Any guys? Anybody in the chat? Any ideas? Nobody? Okay, the reason for this is because take a look at our window. We decided that the values x and y were going to be from 4 to 10 and from 130 to 396. The reason why this is a problem is because the value that we are finding, 20 minutes, is outside of our window. The x value is all the way up to 10. So we need to change that value. Let me write it here, for example, 30. Now, it is also going to give us a mistake here because I just changed the value, the window for x, but I have not changed the value of the window for y. And this is most likely to be that the y variable is going to be bigger than 396. Let me show you that graph. This will be the new graph, right? So if I press second calculate, I can find the value, and then 20. Enter. Ah, look at that. It wasn't an issue now. Okay, so if you just fix it for the x, for the domain, things are going to be fine. So we know now that the result for y is going to be 768, which is this one. We look at that. 769. And ours is 768. Why do we have a difference of 1 digit, of 1 unit? Why is the calculator saying this is the answer while the book is saying this is the answer? This is not a mistake in the book. This is a mistake on my part because I decided to use this function, the simplified function, remember? If I were to use this one in here, the one without simplifying, then my result will be more accurate and it will be more precisely 769. All right, cool. So I teach you already the two methods. Number one, use your calculator. This is usually what people do in an exam or a quiz or whatever. This is what usually people do. Method two, simply replace in the function, in the equation, the value that you want to look for. So here, instead of x, change it for 4.5. And for the second question, instead of x, change it for 20. That is it. All right, let's go for the last question. Comment on the predictions made in part F. Right, these are predictions, right? Estimating is a prediction because we don't know the value for 4.5 and we don't know the value for 20 minutes. We don't know these values. So estimating is a prediction, right? So what would be the comment in here? All right, take a look at this. We know that at 4 minutes, we have a temperature of 150. And at 20 minutes, we have a temperature of 769. But take a look at this. What the book is saying is the answer to 1, so to this one, is appropriate because this 4.5 is within the domain of the model. But the second one at 20 minutes is not so good, right? This is called extrapolation. And extrapolation is risky because we know that in these points, we know that, let me take a screenshot of this. All right, because we know that in these 4 points, these, and these, so these values of x and these values of y, we know that for these values of x and for these values of y, the behavior of the data is linear. But in all honesty, we don't know what is going to happen if we put another point there? Maybe the point is there, or maybe the point is here, and then the next point is there, and then the next point is there, and then the next point is there. So extrapolating comes with a risk. Interpolating can give us a little bit more tools to find values. If we want to find a value here, we know that it's between a linear model, so it is most likely to be linear. But this point in here is outside of our model. So this point could not be linear. This point, look at that, it's not linear according to the other four. It's linear to this, but not to the other four. Did you see? So extrapolating comes with that risk. Now, un momentico en español. Para ser una persona crítica, yo también diría, ok, pero interpolar también viene con un problema, porque la verdad es que uno conoce el movimiento de estos 4 puntos. Déjenme lo tomo acá. Uno conoce el movimiento de estos 4 puntos, pero tal vez un punto en el medio, digamos si elijo un puntico en X acá, ese puntico podría ser en Y aquí. La verdad es que no sabemos. Si tomo otro punto en X en el medio, ese otro punto en X puede ser aquí. Y la función puede ir así. Eso podría pasar. Eso podría pasar. La realidad es que no sabemos, así que ambos interpolar y extrapolar vienen con un riesgo. Pero generalmente ambos, interpolar y extrapolar. Aquí estoy interpolando porque estoy eligiendo valores que están dentro del dominio, ¿no? Mira, aquí está el dominio. Estoy eligiendo valores dentro del dominio, así que estoy interpolando. Pero interpolar también viene con un problema, con un riesgo. De todas maneras, en matemáticas, por el comportamiento normal de las cosas en la vida, por lo general, interpolar es más seguro que extrapolar. Para futuro, uno la verdad que no sabe cuál será el comportamiento. Ok, entonces déjeme borrar todo esto. Bueno, pasemos acá. Risk of the tendency may not continue after 20 minutes. 20 is now within the domain on which the model has been defined. So extrapolating comes with a risk. It is up to you. It is up to you if you want to accept the results of the extrapolation or not. Sometimes extrapolating is good because you have enough trust in your model. Sometimes extrapolating is not good because you just don't believe your model. So that is the comment there, all right? Cool. So let's get to work with our exercises. All right, in here we have 1, 2, 3, just 3 exercises, absolutely simple ones. Guys, I want you to take a look at man, we don't have enough time. You know what? Do all of these 3. Guys, for today, we were going to continue doing some other things. But if we cannot do those other things, that is okay. We're going to have to do them later. Take a look at these 3. Give them a try. Again, these exercises can be hard sometimes. So I want you to try it. To give it your best. 2, talk among your partners, right? I know that things are difficult because you don't have your partner next to you. But guys, we have cell phones, right? We have WhatsApp. You can speak with your partners, right? You can mute me if you want to. And just speak with a partner and say, hey, I don't know, Majo, how much did you get in the first one? This is a 7, right? Oh, no, it wasn't a 7? Okay, why? You can do that. Please work with a partner. Even though you don't have your partner present, work with a partner, guys. And as always, if you have any doubts, you can always ask me, guys. All right, cool. I'm going to stop the recording here. Let's get to work.